This is another video of how do you solve rational inequalities. And this is a more complicated example. I've got x minus 1 over x plus 2 is larger than 2. So I'll go through the same 5 steps that we did in the last video. So the first thing we'll try to do is get 0 on a side. So move that 2 over. And so I'll subtract 2 to both sides. And remember, there's one additional part to step 1 where, if necessary, we need to get a common denominator for our rational function. So I need to combine x minus 1 over x plus 2 with the negative 2. I need a common denominator there, which would just be an x plus 2. So what did I do? I multiply the top and bottom of negative 2 by x plus 2, x plus 2. And so if you were to distribute that negative 2 through, that's where you're going to get minus 2x minus 4. And then now you can write that as a single fraction, everything over x minus 2. Finally, combine your like terms in the top, and you get a minus x minus 5 divided by x minus 2 is larger than 0. So what we will play with from now on for the rest of this video is this. And from here on out, it's pretty similar how to solve this to the last video, but we'll just go through the steps again since maybe this stuff's still kind of new. So number 2, you're going to factor the numerator and denominator if necessary, and well, it's already done for us here. So what do I mean by if necessary? If it's not already done for you, it's always what you need to do. And remember that that's important because that'll make it easy for us to figure out what are the zeros of your rational function and what are the vertical asymptotes of the rational function. And what we'll do is we'll find those values of x that determine both of those things, and we'll plot them on a number line. So I'm looking at minus x minus 5 over x minus 2. Remember, you look in the numerator for the zeros, that tells you x has to be negative 5. And you look in the denominator for the vertical asymptotes, and that tells you that x equals 2. Remember that vertical asymptotes, that's saying that it does not make sense to plug in x equals 2 into this rational function, right? You'd be dividing by 0, and that's one of the few things that you're never allowed to do in life. So I'll plot that information on this number line, and similar to the last video at the example that we had, that just splits the number line into these 3 different pieces: the orange piece, the blue piece, and the pink piece. That leads us to step 4, where we will pick a test point in each one of those 3 subintervals that we just determined. We'll pick a test point in each one, we'll plug them into our rational function, that's, you can see in step 3 there, the minus x minus 5 over x minus 2. We'll plug that test point into that and just see what the sign is. Is it positive or is it negative, what you get? And so if I do that, I'll pick these test points here. Remember, it does not matter which test points you actually picked. I just picked ones that I thought were convenient. And what I will do is I'll organize this information in a little table to the right. So what am I saying to you? What am I doing here? I'm going to take negative 6 and I'm going to plug it in for these x's that I see. So that would make the numerator positive when you combine everything, right? Positive 6 minus 5 divided by negative 6 minus 2, still negative. And so overall you get a minus. And so that is us plugging those values into our rational function again, and all you care about is the sign. I don't care what actual number it is. And then we will just take these signs that we found and actually put them with the subintervals that they go for. And so we'll use that in the next thing. So just to remind you, I'm saying that this orange interval now is related to, it has a minus sign. And so we're saying that there's a plus sign that's assigned to this blue interval, and we're finally saying that there is a minus sign assigned to this pink interval. Now what we'll do is we'll say that a little bit more. Which ones of these do I want? So we'll use those signs above in order to figure out which one of those subintervals, the orange, the blue, or the pink, or some combination of them, which ones actually solve the inequality that you have. So you'll go back to this one. This was our simplified inequality where we compared to 0. And what does this tell us that we want? Well, that greater than 0 tells me that I want plus signs, and since it's a strict inequality, since there's no equal to here, you're going to use parentheses on the zeros as well. We're not allowed to actually be 0. So let's put this picture back where we assigned assigned the signs of each subinterval. Now I want the plus sign, so I want the blue interval. And maybe in some sense, in some way, maybe these are easier whenever it's a strict inequality like that, because it's just parentheses everywhere. So we're just going to, for a final answer, where I got a plus sign was from minus 5 to 2, and that's our final answer.